Hello friends, this is Gurleen Singh from Infinity Vision. Today we'll be discussing relations and functions NCERT solution of exercise 1.3. So exercise 1.3 is basically about composite functions and inverse of functions. So it's a very interesting exercise. Let's go through all the questions of the NCERT one by one. Okay. So let's see the first question. The first question is, let f be from 1, 3, 4 to 1, 2, 5 and g from 1, 2, 5 to 1, 3. This is given by this function, which means the value of function x fx at 1 is equal to 2. So this is the meaning of these ordered pairs. These are xy ordered pairs. So first is the x, second is fx. Similarly, f of 3 will be equal to 5, f of 4 will be equal to 1, and here g of 1 is equal to 3, g of 2 is equal to 3, and g of 5 is equal to 1. So what do we have to find? We have to find g of f, which is nothing but g of fx. So g of f of x, this is what we need to find, right? So first we'll start with x is equal to 1. So we get g of f of 1. This is equal to g of f of 1. Now what is the value of f of 1? This is equal to 2. So this is equal to g of 2, which is equal to 3. So very smoothly you have to solve these questions. Okay. First you have to see the value of f of 1, then put that value of f of 1, then we have to see g of 2. Similarly, if we see g of f of 3, this is equal to g of f of 3. Now what is the value of f of 3? This is equal to 5. So this becomes g of 5, which is equal to 1. Similarly, if we need g of f of 4, so this is equal to g of f of 4. Now what is the value of f of 4? This is equal to 1. So this becomes g of 1, and this is equal to 3. So this is how we find out g of f. Okay. So g of f of 1 is 3. G of f of 3 is 1. G of f of 4 is 3. So let's move on to the next question. Next question is about properties of composite functions. Okay. So first is, we have to prove if we have three functions f, g and h from R to R, f plus g of h is equal to f of h plus g of h. So let's try to solve this. We have f of g, we have f plus g of h. So what does this mean? This actually means we have f plus g of hx, right? This is the meaning of OH, right? So this becomes f of hx plus g of hx. Okay. So what is f of h of x? This is equal to FOH, and this is equal to GOH. Hence proved. So this is just 3-step question. First you have to write this as h of x, then these get split down, right? This becomes f of h of x plus g of h of x. then this becomes FOH A plus GOH. Now similarly we have to prove for multiplication. So for case of multiplication we get F of G of F times G of H. So this is equal to F times G of Hx. Now this will be similar in the case of multiplication. You get F of H of X multiplied by G of H of X. This is nothing but FOH. This is nothing but GOH. Hence proved, right? So this is how we solve such questions. Moving on, we have next question where we have to find GOF and FOG in both these cases. So first, let's start by G of F, GOF function in case of this. So GOF in case of this is G of F of X, which is G of mod X, right? So what is G of mod X? This is equal to 5 times mod X minus 2 whole mod. Now it's very easy. We just have to substitute the value of X here as mod X, because we have to find G of F of X. So X value will be replaced by mod of X. We get 5 times mod X minus 2. Similarly, if we find FOG function, this is F of G of X, right? Now this will be equal to F of mod 5x minus 2, right? Now what is F of X? This is equal to mod X. What is F of mod 5x minus 2? This is equal to mod of mod 5x minus 2, which is nothing but mod of 5x minus 2. So this is how we find FOG and GOF in these cases. So moving on to the next part, we have to find GOF in this case. G of F of X. This is equal to G of F of X. This is G of 8x cube. That is the value of fx, right? Fx is equal to 8x cube. Now we have to find G of 8x cube. So this is equal to 8x cube to the power 1 by 3. Now if we calculate this value power 1 by 3, we get 2x. So GOF x is equal to 2x. Similarly, we'll find FOG x. This is equal to F of G of X, right? Which is nothing but F of x to the power 1 by 3, which is nothing but 8 x to the power 1 by 3 cube, right? We just have to substitute the value of x, replace the value of x with x to the power 1 by 3. So if you replace x with x to the power 1 by 3, this x becomes x to the power 1 by 3. If you power it to 3, this becomes x. So answer is 8x. So these are GOF and FOG in this case. So let's move on to the next part. So next is, a function is given fx. Show that f of x is equal to x for all x except x is equal to 2 by 3. What is the inverse of f? So first we'll just find f of x. This is equal to f of x. What is the value of fx here? This is equal to f of 4x plus 3 upon 6x minus 4. You substitute this value in place of x here, right? Now this is very important part. You have to find f of this whole thing, right? So you have to replace this x here and this x here with this whole thing. So this becomes very lengthy, but still you have to solve it. 6x minus 4 plus 3 upon, you get 6 times 4x plus 3 upon 6x minus 4 minus 4. So now you have to solve this whole equation. Okay, we take LCM, we get 16x plus 12 plus 18x minus 12 upon 6x minus 4 upon 24x plus 18 minus 24x minus 16. So this is what we are getting. Right? So if you solve this, no, you're getting plus sign here, because this minus minus will get plus here. Upon 6x minus 4, 6x minus 4, 6x minus 4 cancel, 12, 12 cancel, 24x, 24x cancel. You are left with 34x divided by 34, which is equal to x. So therefore, f of x is equal to x. Therefore, the inverse of f is f itself. Okay. So if we have g of f of x is equal to x, in such case g is the inverse of fx. But if this is the case that we are getting f of x is equal to x, in this case f is inverse of f itself. Okay, so that's how we solve this type of questions. Moving on to the next question. So we have to tell with reasons whether the following functions have inverse or not. Okay, we'll start with the first question. In first question, f1 is equal to f2 is equal to f3 is equal to f4 is equal to 10. Therefore, this function becomes many one function. Now we know that if function is many one function, then its inverse does not exist. For inverse to exist, this function should be a bijective function. Okay, which means it should be 1, 1 and on 2. But this is many one function, therefore its inverse is not possible. Similarly, in this case, we see that f of 5 is equal to f of 7 is equal to 4. Right? These two values have same answer. Therefore, sorry, this is g function. We'll write this as g. So g of 5 is equal to g of 7 is equal to 4. Therefore, this is also many one function. Therefore, inverse does not exist. Okay. In this case, let's see. For x is equal to 2, we are getting 7. For 3, we are getting 9. 4, 11, 5, 13. So all values have different answers, right? And all the elements in codomain are present in the range. Therefore, this function is 1, 1 as well as on 2. Right? Two reasons. Because 1, 1, because every element has distinct image. No two elements have same image. Right? And why is this on 2? Because 7, 9, 11, 13, these are all the elements from the codomain and they are all present. So therefore this is on 2 function. Therefore its inverse exists this is an invertible function. Okay. So let's move on to the next question now, which is the sixth question, which says show that the function f from -1 to 1 to r given by fx is equal to x upon x plus 2 is 1, 1. Find the inverse of the function f, and the hint is given for range, for y belongs to range of f, y is equal to fx is equal to x upon x plus 2. For some x in -1 to 1, that is x is equal to 2y upon 1 minus y. So let's just focus on this question. We'll see the hint later. We need to show that this function is 1, 1 function. So the condition for 1, 1 function is if we have fx1 is equal to fx2, then x1 should be equal to x2. So we get x1 upon x1 plus 2 is equal to x2 upon x2 plus 2, right? You cross multiply, you get x1 x2 plus 2x1 is equal to x1 x2 plus 2x2. So we get x1 is equal to x2. Therefore, we say that this function is 1, 1 function. And it's very easy to show that this function is onto function as well. To prove that this function is onto function, what we do is we suppose this fx is equal to y. Now this becomes x upon x plus 2. We cross multiply and we calculate the value of x here. So we get xy plus 2y is equal to x. X is equal to 2y upon 1 minus y. Okay, so this is the value of x here. Okay, for all values of y, there will exist a unique value of x, except this value y is equal to 1. Okay, so therefore this is the inverse of the function. Okay, and this also proves that this is a non-to function. You find this value of x, you substitute it here, okay, you will get the value y again. And this is the inverse of the function. So this is how you calculate the inverse of the function. You equate this to y and then you calculate the value of x in terms of y. So let's see the next question. Consider f from R to R given by fx is equal to 4x plus 3. Show that f is invertible. Find the inverse of f. So to show that this is invertible, we have to first show that this is a 1, 1 function. So we get 4x1 plus 3 is equal to 4x2 plus 3. Solving, we get x1 is equal to x2. So this is what we get. So if we have fx1 is equal to fx2 and we get x1 is equal to x2, we show that this is a 1, 1 function. For onto function, this is pretty easy. You equate this to y. Y is equal to 4x plus 3. You calculate the value of x, which is equal to y minus 3 upon 4. Okay, and you substitute this value again here. You get y is equal to 4 times y minus 3 upon 4 plus 3. So if you solve this, you get y. So this will be the inverse of the function, and since there is no restriction on x and y, therefore this is an onto function as well. So therefore this function is invertible and this is the inverse here. Let's see the next question. So this function is defined from r plus 2, 4 to infinity, right? given by fx is equal to x squared plus 4. Show that this function is invertible and find the inverse of f. So it's very easy question. You have to see that first we have to show that this function is invertible. For 1 function, again same condition, fx1 is equal to fx2. So you get x1 square plus 4 is equal to x2 square plus 4. You get x1 square is equal to x2 square. You get no negative values because this function is defined from r plus. So therefore we get x1 is equal to x2 here, right? So therefore this function is 1 function. For on 2, let's see, we get y is equal to x square plus 4. You get the value of x square is equal to y minus 4. Now since this x square is positive, y minus 4 will also be positive, right? And we are taking only positive values of x, therefore x is equal to square root of y minus 4. So this will be the inverse of f, and since for all y belong to R, there exists x belongs to, for all y belong to not R, this will be y belongs to 4 to infinity. There exists x belongs to R plus, such that this condition is satisfied, right? So this is onto function, and this will be the inverse of this function, right? So let's move on to the next question. So next is, function is defined fx is equal to 9x squared plus 6x plus minus 5. Show that the function is invertible with f inverse y is equal to this. So how do we find inverse in such cases? So you can simply prove this, that this is invertible by proving that this is 1 and on 2. Okay, we'll focus on the inverse part. How do we find inverse? We equate this as y. We get 9x squared plus 6x minus 5 is equal to y. Okay, we try to make it a perfect square, complete square. So by completing the square, we get 9x squared plus 6x plus 1 minus 5 minus 1. Okay, so if you complete the whole square here, you get y plus 6 this side, and you get 3x plus 1 whole square this side. Now see, since y is from minus 5 to infinity, therefore this thing will always be positive. For minus 5 to infinity, this thing will always be positive. So if left hand side is positive, right hand side be positive, so we'll only be dealing with positive cases. So we get 3x plus 1 is equal to y plus 6 with a root, right? So if you calculate the value of x from here, you get x is equal to root y plus 6 minus 1 upon 3. So this will be the inverse of fx. Alright, so let's move on to the next question. Next is, x to y be an invertible function, show that f has a unique inverse. So we have to suppose that there are two inverses, and then we have to show that there can be only one inverse, and f has a unique inverse. So let's suppose that G1 and G2 are two inverses. So this is what we have to suppose to start the question. So what we get is f of G1x or G1y is equal to f of g2y. Okay, so I'm more comfortable with x, so I'm just taking f of g1x is equal to f of g1y, and this is equal to iy and y. Okay, we're writing in terms of x, so let's write this x. So now what we get from here is, if we have two functions f g1 and g2 such that this condition is getting satisfied, so we know that f of g1x is equal to f of g2x. So this condition will be satisfied. This is what we mean by this, right? So now f of g1x and f of g2x, this will be equal only if g1x is equal to g2x. And why is this? Because this is a 1-1 function. So therefore g1x is equal to g2x. Therefore g1x is equal to g2x. Both functions will be equal and they will be equal to the inverse of f. Right? And why is that? Because f of g1x and f of g2x both are equal to identity. So let's move on to the next one. Next one is, consider a function from 1 to 3 to abc defined by f1 is equal to a, f2 is equal to b, f3 is equal to c. So this function is given. We have to find f inverse and show that f inverse of this inverse is equal to f. So if we have double inverse, we have to prove that this is equal to f. So in this case, we have to assume a function gx such that g goes from abc to 1 to 3 and GA is equal to 1, GB is equal to 2, GC is equal to 3. So if we take such a function gx which is satisfying this condition, then what will be g of f of 1? So g of f of 1 will be g of a, which will be equal to 1, right? So therefore in this case g of f of x will be equal to x, and similarly f of g of x is equal to x in both cases. So this will be the inverse function of fx. Now we have to find the inverse of this inverse function, right? Since if f inverse is g, so we have to find g inverse, and we have to prove that this is equal to f. So it's very easy, right? So you can easily find the inverse of this. You can take such a function hx, where h of h of 1 is equal to a, h of 2 is equal to b, h of 3 is equal to c. So this will be your function hx, which is now the inverse of g, right? So this whole function will become hx, right? And this is actually equal to fx. So therefore we prove that f inverse of inverse is equal to f. So in this case we have to go by examples, we have to go by assumptions. Okay, it's very easy to see that if f of 1 is a, and if you take some g function such that g of a is 1, then that will become the inverse. So let's see the next question now. So next question is, let fx from x to y be an invertible function. Show that the inverse of f inverse is f, that is f inverse of inverse is f. Okay, so it's pretty similar to the previous question. In this case we have to show that f inverse of inverse is equal to f. Okay, so what we'll assume here is we'll take a function gx. Okay, we'll take a function gx such that g of f of x is equal to f of g of x is equal to I. Okay, so g of f of x is equal to x and f of g of y is equal to y. So we'll take such a function. So in this case, let's see if this is the condition which we are getting. In this case, g will be inverse of f, right? But f inverse is actually the inverse of fx. Therefore, f inverse is equal to gx. So therefore, f inverse will become the inverse of fx. Now in the next condition we have to prove that f inverse of inverse is equal to f. So now what we can do is we'll take this function f inverse, okay, which is actually g, and now we want to calculate the inverse of that function. So that function, let's say that function is hx, okay, let's say this whole function is hx. Now g of h of x will also be equal to x, but we know that g of f of x is equal to x. Therefore, if g of h of x is equal to g of f of x, if these are both invertible functions, then hx is equal to fx. Therefore, we get f inverse is equal to f. Right? So let's see the next problem now. So next problem is, in this case we have to find f of x. So what is fx? It is given by this. So f of x is equal to f of 3 minus x cubed to the power 1 by 3. So we just put the value of fx here, right? And now we have to put this value of x over here, right? So this becomes 3 minus, so in the place of x we substitute this whole term, 3 minus x cube to the power 1 by 3 cube to the power 1 by 3. Now if you simply open the brackets, you get 3 minus, so this power 1 by 3 and 3 cancel, 3 plus x cube to the power 1 by 3. So therefore this becomes equal to x. So what is f of x? This is equal to x in this case. So let's see this problem now. We have to find the inverse of this function. Fx is equal to 4x upon 3x plus 4. So what we can do is we can equate this to y. Now calculate the value of x from here. You get 4x is equal to 3xy plus 4y. You calculate the value of x. 4x minus 3xy is equal to 4y. X is equal to 4y upon 4 minus 3y. So is this the answer? This is the B option. So that's how you calculate the inverse. So that is all from my side. So this was the NCERT solution of exercise 1.3. Stay tuned for more videos. Keep watching Infinity Vision. Thank you.